And what we're going to do in Bayes' theorem, all right, so let's just say Bayes' theorem, it's going to give us P of S2 given I1. That means the consultant has said that S1 will happen, right? I1 is the event that the consultant utters something, says something. What is the consultant saying? I think S1 will happen, right? So the consultant said that. Now, if the expert said that, what's the chance that S1 will happen or S2 will happen? In our example, we saw the S2, so let's calculate that first. P of S2 given I1 has happened. What is that? Now, first thing first is P of S2. That means we count the S2 that is inside I1, isn't it? That's 3. Count of S2 inside I1 is the same as count of I1 inside S2. So that's 3. 3 divided by count of I1, 3 divided by 7. That is going to be 3 divided by 7, right? About 0.42 something. So let's see if we are able to get that right. So count of S2 inside of I1, right? Divided by C of I1. So that is going to be what? Count of S2 inside I1 is the same as I1 inside S2. So this divided by count of I1. Where's count of I1? Okay. All right. And same thing, we can calculate P of S1 given I1. That's count of S1 inside I1 divided by count of I1. Yeah. So again, that's count of I1 inside S1. Same. You can flip them and it's going to be the same. Okay. Now, well, why don't we finish them all? P of S2 given I2. Count of S2 inside I2 divided by C of I2. So that's going to be here, this one divided by, oops, sorry. So that's going to be this one, I2 inside S2 divided by count of I2. So luckily we have that. And finally, we have S1 given I2. And that's going to be count of, well, extra bracket here. Count of S1 inside I2 divided by count of. So finally, we get I2 in S1 here divided by count of I2. Okay, great. So we have these that are basically derived, yeah, and predicted by Bayes' theorem. So let's see if Bayes' theorem actually is going to give us that. And for that, we want to use a tabular approach, a table method. I'm going to show you now. And we'll tabulate S1 and S2 by the side here. We'll put a prior probability. The prior probability is going to be the input, okay, P of S1. Yeah, so we can put prior here, P of SI, SJ. And again, we can copy it from here. Okay. Then we have P of I1 given Sj. P of I2 given Sj. So this is the credibility matrix. So given S1, what is P of I1? So that's exactly this one. So we'll say equal to this. Given S1, this one, what's the P of I2, right? So that's exactly this one, right? The same row is going to talk about S1 here. So it's very clear, right? And same thing here, given S2 was P of I1, given S2 was P of I1, this one, and this one. Okay, so well, we can color it slightly differently. And these are the inputs as well, right? So it's supposed to be yellow. Well, it's supposed to be yellow, but we will slightly distinguish the prior probabilities like that. So it's a slightly different yellow. Okay, orangey. All right. Then we have so far these are the inputs, so 6 numbers. And to achieve Bayes' theorem, right, we want to first of all compute P of I and Sj. That means P of I1 inside S1, P of I1 inside S2. So the inside is actually intersection, or you think of it as and I1 and S1. I1 intersect S1. I1 inside S1. So they're all just words to help us compute. And the way to think about it is you want this number to be multiplied by this number, kind of split the prior probability by the credibility matrix. Okay, and then here is you want same thing, the prior probability to be multiplied by this number. So split the prior probability by these two corresponding fractions. And then we will copy and paste and check that it is splitting the bottom prior probability by the credibility matrix. Okay, and what is interesting is if we add up vertically this column, yeah, and likewise this column, just add it vertically, it is actually giving us P of I. So here, this is actually P of I1, P of I2. Very interesting outcome here. And what does P of I1 mean? It means the probability of I1 happening. What is that? Probability of the consultant saying S1 will happen. Remember, I1 is the consultant saying it out loud as a fact that S1 will happen. So if we wonder, will this consultant predict S1 or S2? Well, over here we can tell it is more likely, right? Twice as likely that the consultant will predict S1. Okay, so all these are intermediate calculations, and that will lead us to the final Bayes' theorem, where we have P of Sj given I1, P of S1 and 2 given I2. So what is that? Very simple, right? Here we did one multiplication to get the gray cells. We did one addition to get the green cells, and we're going to do one division, which is this divided by its own column total, right? Don't get it wrong, there's no row total, so column total. So here, we just basically use the cell divided by its own column total will do. And then we just copy over this divided by its own column total, this divided by its own column total. Now, these four numbers are the crown jewels, all right, of what we are after. So we are done. So the posterior probability as given by Bayes' theorem is found exactly on the right side here in this one, these four numbers. Plus, what may be of value will also be these two probabilities. Okay, so now over here in this Tableau approach, this table-based approach, we're not doing anything new. We're actually visually implementing Bayes' theorem. So everything about Bayes' theorem is done here. And let's check, right? So we have these four probabilities. Are they correct? P of S1 given I1. That's exactly this, right? P of S2 given I1. Given I1. So that's S2, 0.4285. Yeah, correct. And P of S2 given I2, that's P of S2 given I2, that's the 0.6. And then the 0.3, P of S1 given I2. So far, okay? All right. Now, of course, the numbers I began with was just kind of artificially given 1, 2, 3, 4, 5, 6, right? It could have just been easily altered into fractional forms. And you see that we are not just, luckily the numbers were well chosen. The numbers, the calculations did not burst into something more than one, right? That's not entirely because of luck. That's actually airtight, so we can even put down fractional counts and everything will be okay. So no worries at all. Okay, so I hope now you see how the Tableau approach, writing it down this way as a table, helps us to very systematically and kind of quickly derive the posterior probabilities based entirely on Bayes' theorem calculations. Okay, and when we check with our own one ball, two ball, ball by ball counting, we find that, yeah, actually, this is exactly what is being done by Bayes' theorem. So our understanding is there, our calculation is there, and basically that is how we can easily derive the posterior probabilities when we are given the prior probabilities and the credibility matrix of the consultant. So let's go back to our slides over here, and we can see that basically the Bayes theorem is allowing us to do all this. Okay, so we are using the conditional probabilities, we are doing the multiplications, then we do the addition. All right, and actually denominator here is P of I 1, P of I 1 in this case. And so when we do that, we do one final division to obtain the posterior probability.